Alright, welcome to this page of the notes, and what these example problems here are designed to do is simply to just check how well do you understand the properties of rectangles, rhombuses, and squares. So let's find out. How well do we know these properties? What I've done is I'd like you to draw a figure that shows why this statement, the one I'm about to give you, is not necessarily true. Why does this statement not have to be true? Here's the statement. If one angle of a quadrilateral, keyword right there, if one angle of a quadrilateral is a right angle, then the quadrilateral is a rectangle. I would like you to tell me why that statement does not have to be true. Well, let's draw a quick picture. Remember here, the keyword is this. I tell you it's a quadrilateral. I don't tell you it's a parallelogram. And this is where knowing those properties really well comes in. If I told you it was a parallelogram, then one right angle is enough to say that it's a rectangle. But I don't tell you it's a parallelogram. What that means is I don't have to have two pairs of congruent parallel sides. So, what if I gave you this guy? Right there. I tell you that that's a right angle, and you know that those sides are parallel. That's it. Is this figure not a quadrilateral? Remember, a quadrilateral has four sides. 1, 2, 3, 4. I have four sides. And I drew a quadrilateral with one right angle. But is this picture a rectangle? No, it's not a rectangle. So the point is simply this. I would also need to know, in order to prove that it's a rectangle, I would also need to know that the quadrilateral is a parallelogram. That's the only way that this property works. I must also know that the figure is a parallelogram. Right? That's who the property works for. If it's a parallelogram, then one right angle does mean that you have a rectangle. But since you weren't told it was a parallelogram, you were just simply told it was a quadrilateral, then the statement doesn't necessarily have to be true. Could it be true? Yes, it could be true, but it doesn't have to be. So, because I must also know the figure is a parallelogram, no. This statement may not be true. And what am I testing you on there? I'm testing you on that idea. Do you know that it not only has to be a quadrilateral, but it must be a parallelogram in order for you to apply the conditions that we just talked about? All of the conditions for rectangles, rhombuses, and squares. You must know the figure is a parallelogram. Simply telling you it's a quadrilateral is not enough. Not enough. Let's try the next one. Alright, I want you to determine if the conclusion is valid. If not, what additional information is needed to make the conclusion valid? Here we go. I have given you a figure. I tell you that ABC is a right angle. Let me go ahead and draw that information in there, right here in blue. Angle ABC is a right angle. Well, there it is, right there. So there's angle ABC, and there's my right angle. Now, I want you to prove that the figure is a rectangle. I want you to prove that the figure is a rectangle. Okay, well, what do I know? It is true that I have, what did I tell you here? Determine the conclusion is valid? Okay, what I don't see anywhere in here as far as my givens or even in the directions, nowhere do I see the word parallelogram. Nowhere. It doesn't show up. And so while yes, a rectangle has all 4 right angles, the only way I can say for sure that I have 4 right angles is if I know it's a parallelogram. And I am not told that. Okay, so this is a really important idea because now we've seen it in the last 2 example problems. This idea of you needing to be told the figure is a parallelogram, whether it's based on the given information or I just tell you in the directions. If you don't know that it's a parallelogram, you cannot apply the theorems and the properties that we just talked about. I am not told that the figure is a parallelogram, so I cannot conclude that it is a rectangle. I don't know if conclude has an E on the end of it or not. Sorry, I apologize if I misspelled that. I cannot conclude the figure is a rectangle. I simply do not have enough information. Now, if they told me it was a parallelogram and they told me one of the angles was 90 degrees, then yes, that is enough. I know it's a rectangle. But they don't tell me it's a parallelogram, so my hands are tied. There's nothing I can do. Can't go any further. Here we go. Let's try this one. Here we go. So I tell you that EFGH, this guy right here, is a parallelogram. That is really important information. Let me go ahead and put it in red. I'm told it's a parallelogram. So here we go. In EFGH, I'm told that EG and FH are congruent. Let's see, EG, FH. Right there, this is really important here, right here in green. Go ahead and make yourself a little note because this is important. This right here tells me the diagonals are congruent. All right, I got some good stuff here. I know it's a parallelogram and I know the diagonals are congruent. So let's find out what they want to know. Which of the conclusions below is correct? All right, here we go. EFGH is a rectangle. Well, let's think about our conditions for rectangles. Do rectangles have congruent diagonals? Yes. Yes, they do. The diagonals of a rectangle are congruent, as long as I know it's a parallelogram, which I am told. So, yes, this conclusion is valid. Because rectangles have congruent diagonals. Right? That is one of the properties of rectangles. Rectangles have congruent diagonals. So back on the previous page of the notes, we said if you can show the diagonals of a parallelogram, are congruent, then the figure must be a rectangle. You're told it's a parallelogram, you're told the diagonals are congruent, therefore it has to be a rectangle. Let's keep going. I want to know, is EFGH, is it a square? Well, remember, we actually just did one of these. In order to show that a figure is a square, you must show the figure is a rectangle, which we just did. but you also must be able to show the figure is a rhombus. You have to know both. It has to be both a rectangle and a rhombus in order for it to be a square. Well, right here, I know it's a rectangle. Can I prove that it is a rhombus? Well, the properties of rhombuses are this. We know that rhombuses have consecutive sides that are congruent. Am I told anything about the sides? I'm not. We know that the diagonals of a rhombus are 90 degrees. Am I told that the diagonals are perpendicular? I'm not told that. And finally, we know that a rhombus has a diagonal that bisects opposite angles. Am I told anything about the diagonals bisecting opposite angles? I'm not. So, first, consecutive sides. Must be congruent. Which I don't know. I don't know that consecutive sides are congruent. Then, the diagonals must be 90 degrees. Which I don't know. I don't know that. And then finally, the diagonals must bisect opposite sides. They must bisect opposite, which again, I don't know. I don't know that the diagonals bisect opposite sides. Therefore, I do not have enough information to say that this figure is a rhombus. Since I know it's a rectangle, but I don't know that it's a rhombus, I cannot say that it is a square. So, not enough information is given to show this is a square. Not enough information is given to show the figure is a square. The figure EFGH is a square. I'm not saying that it isn't. I'm just simply saying I don't have enough information to say for sure that it is. Guys, thank you so much for joining me for this set of videos and these notes. All we're doing is using the properties of rectangles, rhombuses, and squares to show that a figure is one of those shapes, a rectangle or a rhombus or a square. Had a great time taking a look at this with you. I'll see you guys next time.